I'm going to do a little overview of the notes and work we did in class today. Um, so starting with just defining a sign diagram. You can see here I've written a definition for a sign diagram. It's just a number line showing the zeros of the derivative function. So those zeros would be marked along the bottom. In this case, in this example I have here, the only zero listed is 1, and a zero of a function is just where that function is equal to 0. So it shows the zeros, and then it shows whether that derivative function is negative or positive on the intervals separated by the zeros. And that correlates to where f of x is decreasing or increasing. So we're going to do an example of this, but I just wanted to kind of give you maybe a little more succinct definition of a sign diagram. So you can pause and write that down if you'd like to. Keys here are, I didn't make a mistake by leaving off the prime in that second one. The sign diagram, again, it shows the zeros of f prime of x, which is right here. It shows the negativity or positivity of f prime of x on either side, that's right here. And those things correlate to where the function, the f of x function, is increasing or decreasing. It's showing that the slope of the tangent line is either negative or positive, which tells whether the slope of the whether the function itself is decreasing or increasing. Okay, so here's an example where we're not even given the graph of the function itself, we're just given the original function. And we're asked to draw a sign diagram and then identify the intervals where f of x is increasing or decreasing. So in order to do that, we need to find the zeros of f prime. So we're going to take the derivative of f of x, which is 3x squared minus 12x plus 9. So we've done the derivative. Now we need to find the zeros, or we need to set that equal to 0. And I'm sorry, not 3, 0, and solve for x. So we're looking now just at this portion. The expression for the derivative is equal to 0. We do this by factoring, but I would like to remind you, you can use your graphing calculator to find the zeros as well, and you use the PolySimult app, and it would be the polynomial equation finder or something. But I'll do it by hand right here. I see that all three terms have a 3, so I'm going to factor out a 3, leaving me x squared minus 4x plus 3 equals 0. Notice that the 3 right here, if you divide both sides by 3, it can even just go away right there. And so now, that's just a 0. We can factor this trinomial factors of 3 that add up to negative 4, and that would be negative 1 and negative 3. Negative 1 times negative 3 gives us positive 3. Negative 1 plus negative 3 gives us negative 4. So I could rewrite this in factored form. X minus 1 times x minus 3 is equal to 0. And then the zero product property tells me that each of those products I can set equal to 0, or each of those factors, and solve for x. So that in order for the function value, or in this case, the derivative function value to be 0, x has to either be 1 or 3. And those become our zeros on our number line. Those are, getting back to drawing the sign diagram, I just draw a line. I list those numbers in order from increasing order, chronological order, 1 and 3. And now I choose a number to substitute into the derivative function and determine if if we get a negative or positive outcome. Now, when you have it written like this in factored form, it's pretty easy to do. So I'm going to choose a number in the interval down here below -1. So, I mean, below +1. So 0 is a nice easy one. 0 is below 1, so it's in this lower interval down here. I'm going to just substitute 0 in for x, and I'm going to do this in my head, but I'll kind of write it here. 0 minus 1, well, that gives me a negative. 0 minus 3, well, that gives me a negative. And I have a negative times a negative, which is a positive. So a number less than 1 is always going to give me a positive output because I'll get a negative in my first factor and a negative in my second, and those will become positive when I multiply them together. Now I'm going to choose a number between 1 and 3, and let's just take 2, for example. Put in 2 to x here, 2 minus 1, and I'm going to get, that'll give me a positive number every time. Any number greater than 1 is going to give me a positive number in that factor. Here, if I have 2, so it's greater than 1, but it's less than 3, that's going to always give me a negative number. And then a positive times a negative is a negative. So on my number line, I put a negative in that interval between 1 and 3. And then finally, I choose a number greater than 3. Let's just go with 4. So that is always going to give me a positive number here. 4 minus 1, or anything bigger than 3 minus 1 is positive. 4 minus 3, or anything bigger than 3 is positive. And a positive times a positive is a positive. And this shows us that the graph of the original function, f cubed minus 6x squared plus 9x, is going to be increasing until it gets to 1, and then decreasing until it gets to 3, and then increasing after 3. So we've drawn our sign diagram with these zeros listed and the positives and negatives listed. And now we can identify the intervals by just writing f of x is increasing when, bad writing here, x is less than or equal to 1 and greater than or equal to 3, and f of x is decreasing when 1 is less than or equal to x is less than or equal to 3.